Hey, you guys like that time of the year every year where girls are walking around the neighborhoods or at Safeway or at your local store selling Girl Scout cookies? Well, do you know that they're also learning a little bit how to develop their business sense, looking at some business ventures? And one of the mathematical tools that's helpful for them is this idea of linear inequalities. Now, a linear inequality is very similar to a linear equality, where we might have a standard ax plus b equals 0. That's an equality because we have an equal sign there. An inequality comes in four different shapes, where I might have some ax plus b is greater than 0, some ax plus b is greater than or equal to 0, some ax plus b is less than 0, or some ax plus b is less than or equal to 0. Those are the four shapes, four types of inequalities that you'll see. And I hope that you see that they're fairly similar. One caveat, we want to ensure that our A value is not equal to 0, because if that's the case, then the inequalities don't really work out that well because they're not based on our independent variable. So how do you solve a linear inequality? Well, when you solve a linear inequality, first thing you want to do is simplify. Not too different than what we've done before. The second step, what will work best if you do any additions or subtractions from that variable of x. We're trying to isolate x. The first thing we can do after we simplify is add or subtract any constants. The third thing that we would like to do is to do any multiplications or divisions. And then 4, well, what's our solution? Let's present our solution in a way that makes sense. So let's look at an example and see what that looks like. We have the example 3x minus 5 is greater than negative 17. I lost you guys a little while ago. You're thinking Samoas and Thin Mints right now, aren't you? I get it. All right, first step, simplify. Second step was, since it's already simplified, there's no like terms, nothing I can do, no fractions to resolve or whatever it might be. Let's add or subtract. Now this x is what I'm trying to solve for. This negative 5 is being added or subtracted to this term that has the x with it. So let's add a 5 first. So that becomes 3x is greater than, what is that, negative 12. Step 3, any multiplications or divisions. I can divide both sides by 3. And I'm left with x is greater than negative 4. So what does that tell me? It tells me that this linear inequality that we started off with becomes true for all x's greater than negative 4. Doesn't become true if x equals negative 4, since there's no greater than or equal. Its only value is greater than negative 4. How do we provide that solution? There's two ways that are typical that we'll use. One is a graphical solution, which means we'll draw a number line. We'll look at the breakpoint, which in this case is negative 4, and I'll just graph that randomly, usually there in the middle. And then I'll choose a test point to find out what side do I shave in. I know there's a point over here that's like 0. I'll look at this equation. Is 0 greater than negative 4? No, it's not. So that means all the values on that side are not correct values. Rather, no, sorry, 0 is greater than negative 4. Yeah, 0 is greater than 4. Duh. So that means that this is a true value. I was thinking cookies too. So I'll shade in all those values. Well, what do I do at the point negative 4? Negative 4 in this case is not a true value. So there's two ways that people represent this. One way is they'll put a circle around it and they won't fill it in. And that will represent that the solutions approach negative 4. Another way that some people might graph these is they'll put a soft bracket at that point, which also represents the solutions approach negative 4. We'll show you later what do we do when we see a solution is at the breakpoint. And my favorite is this interval notation. Interval notation reminds us that we put the two endpoints of our solutions. We know that one endpoint is -4. The other endpoint is all the way out at infinity. Then I'll put a soft bracket around the -4 to represent that a -4 is not a solution. And then infinity is kind of an odd one. Since we can't really pinpoint infinity down to a precise number, we'll also put a soft bracket around that as well. Anyway, hope that was great. Next time the Girl Scouts come around, make sure you buy a box.